All right, so let's start our lecture today. So, yeah, so last time I think I end up with, yeah, some scenarios about this M and N here. So, let's see, what did I argue? Yeah, so I argued that if I have, okay, so suppose this modulus of omega 1 is equal to k times modulus of omega to the 2 plus some remainder s, right? And then where we have so then I have the region. So this is region 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so so this is like my omega 1 tilde, and then this is my omega 2 tilde. And then I'm assuming that this omega 1, the modulus of omega 1 tilde is bigger than this omega 2 tilde. Okay, so yeah, so then let's say if okay, so I remember that I have this, I'm trying to analyze, and okay, so trying to analyze this is m omega 1 tilde plus this m omega 2 tilde. Okay, so case 1, okay, so let's say m equal to 1, and then if so then for 1, so what do I want to say? So sorry, it should be 0, right? So less than equal to k, less than equal to, sorry, 0 less than equal to n less than equal to k minus 1. I think in this case it should be k, right? Then I have that this m, okay, so omega 1 tilde plus n omega 2 tilde. Okay, so it lies inside this 8, right? Okay, and then I think I'm equal to 2 then for 0, yeah, so 0 and 2k minus 1, okay. Oh, actually I think it's 2k, okay. Yeah. So then we also have the same thing, okay. Okay, so, and then, okay, so, and then, so, okay. And then, this is the case for region 8, okay. So now let's talk about this region 2, right? So what letter do I use? Okay. So I'm equal to 1, I'm equal to 2, okay. So let's see, so then I'm equal to 1, and then so now I want this n to be bigger than this k, right? So then I have m omega tilde 1 plus n omega tilde 2 is in these two. Okay, so, and then what I'm having is that I'm having, so n equal to 2, then for n bigger than, so now what does it needs to be bigger to? 2k plus 2, okay. I think this is safer, right? So I think this is safer. So, because I think 2k is not enough, okay. Okay, so, yeah. So, okay, so, yeah, so then, okay, so and so forth, okay. Yeah, so in general, right, so I need to have, okay, so I think a general rule is that, so if I have that this n is bigger than mk plus n, then it must be true, right? Yeah, I think this is sufficient. Yeah, but it may not be necessary. Okay. So yeah, I think in this case it also works, right? So in general, so what we have is that so for this n less than or equal to mk, right? Okay, so then I also have the same thing. Okay, m omega tilde 1 plus n omega tilde 2 is the okay, so okay, so let's see whether we can get some cancellation here. So if we have what? So let's see. So in general, if okay, so let's look at this m equal to 1 case. Okay, so if we are in this m equal to 1 case and n is equal to, okay, so let's say so pick m equal to 1. Oh shoot, this is not true. So actually I think it's a negative m, right? Right, okay. Okay, so yeah, so pick m equal to 1 and also n equal to, let's say, k plus 1. Okay, so then I would have this omega, which is equal to negative omega 1 plus k plus 1 omega 2. Okay. Okay. So okay, so what is the side ratio? Okay, so this triangle, okay, so what angle does it have? So this is a triangle of length modulus of omega 1 and also k plus 1 times modulus of omega 2, right? Okay, so okay, so let's use this. Okay, so let's just interested in this angle. Okay, so let's draw this triangle here. So, by the way, this is 90 degree. Okay, so we have the opposite. Okay, so we have the opposite. Okay, so this is the angle theta. Okay, this is 90 degree. Okay, so we have the opposite side. Okay, adjacent. Okay. Great. So actually, okay, let me draw this one. Okay, so let me draw this one. This is theta, this is 90 degree. Okay. So I'm having this length as what? This length as k plus 1 modulus of omega 2 tilde. Okay. And then I'm saying that this is adjacent, right? Modulus of omega 1. And then right, so okay, so what is the slope here? Yeah, I'm not sure about the slope. Okay. Alright, so let's just leave it for now. Okay, so let's see whether I see. So which way do I need to draw it? I think do I draw it this way is better? Okay, so okay, I think okay, let's call it theta. Okay, so then you have the opposite as k plus 1. modulus of omega to the 2, okay. And then this adjacent, which is wait, no. The opposite is the other way, okay. So the opposite is just omega 1, modulus of omega 1. And then, so this is like k plus 1. Okay, so omega 2 to the modulus of omega 2 to the, okay. Okay, so let's see. So can I find some similar triangles that lies in the region 8? Okay, so question. So, can I find some similar triangles in region 8? So, namely, okay, so namely, I want something that's, okay, so, I think you may not be able to find it, right? Yeah. So this omega 1 is okay, so let's change another aspect. So let's say we are like keep adding those, right? So we are keep adding these. Like keep like the n like increasing in this scenario, right? So. So do we actually have so do we actually if I sum them up together, right? So if I'm just keep adding and adding those, yeah. So if I'm just keep adding those, are these sums gonna be cancelled out in some way? keep adding the sums in this 2 and 8, are they going to cancel out? Okay. So okay, so when we are trying to add a sum in 2, right? So what do we get? So so basically so in one line, okay. So so let's just keep it m equal to 1, okay. So okay, so what do we get in this scenario? So if I am keep adding let's say k or this n so n bigger than n from k plus 1, okay, so to infinity of okay, so negative omega 1 to the plus n omega 2 to the, okay. Okay, so so I should use 1 over this guy squared. Okay. Okay. So how? Yeah. So I need to find a way to really give me like the corresponding angle, right? So how do I find the corresponding angle if I have omega 1 and also this n omega 2? So is there any way that I can find this angle here? So these angles, they are supposed to be getting so if I view this, if I view the angle as a theta here, so then these angles are getting smaller and smaller, right? So and then they live in region 3 actually. They're living in the third quadrant after we double the angle, and then we live in the third region. So okay, so what do we do? I want to find a way that allows me to do some yeah, I think I have a problem right now. So I don't think there is exact way for me to express this angle if I know the side length. Except I can use the arctan. Okay, so okay. Okay, so I think instead of using the angle, I think maybe it's more efficient for me to use just the like the usual complex numbers in order to do the calculation. Okay. So okay. Okay. So now yeah, I figure out it's a little bit awkward here. Okay, let me try this. Okay, let me try this. So, okay, so we also assume that this, let's say, omega 1, which is equal to, let's say, come on, give me a name. So, A1 plus I B1. Okay. Okay, so and then let's say omega 2 to 2, which is equal to A2 plus I B2. Okay. Okay. No. Okay. A1 minus I A1. Okay. Because I'm assuming that it lies in that 45-degree line, so therefore it should be that. And then this omega 2 is A2 plus I A2. Okay. Where you have the A1, A2. They are all positive number. Okay. All right. So. Okay. So now, can we let's calculate this guy? Okay. Let's see. So. Okay, so let's see what happened with this 1 over this guy. Okay, let's pick a single one to calculate. Okay, so here, okay, so minus omega 1. Okay, so minus omega 1 becomes negative A1 plus IA1. Okay. And then plus what? N omega 2, right? So what is N omega 2? So N omega 2 is exactly NA2 plus I and A2. Okay. Alright, so and then whole thing squared. Okay, so now yeah, okay, let's see. So so let's simplify a little. Okay, so for the real part, we have the so for the real part, wait, which part dominates the real part? Okay, so since I know that it lies in this region 2, right? So the real part must be positive. Okay. Okay. So here, basically this NA2 must dominate this negative A1, right? So. Okay. So this is a positive number, right? Because this N star is K plus 1, and then we also have that this is I times, okay, I part, there's no doubt, right? So we're just adding this I part, okay. So I plus A1 plus A2, okay. And then whole thing squared. Okay. So now, what does this one equal to? So this is equal to 1 over. Okay. So let's see. So here we have this guy squared, right? So let me write down carefully here. Na2 minus A1 squared, and then minus this one squared, right? Okay, and then plus I times this times this one, so 2I times Na2 minus A1 times the other guy, A1 plus Na2. Okay, let's see whether it's included in, okay, good. So, okay, so so this is equal to what? So I break it down here. Okay, so let's break it down. So here we have that n squared A2 squared minus 2n A1 A2 plus A1 squared minus A1 squared minus 2n A1 A2 minus n squared A2 squared. Okay. And then plus okay, so do I expand this with the imaginary parts? Wait, depends on like what do I want to calculate. So I want to calculate the inverse. Okay, I want to see if I can get some conjugates. A2 squared and then plus A2. Oh, okay. So this one is a perfect. It's a formula for the square sum. The square difference formula. Okay. I think maybe I can just expand it. Okay. So 2I. Okay. So this is equal to exactly n squared a squared minus a1 squared. Okay. So, okay, let's look at this one. So this a1 squared is being cancelled out, and then this n squared a2 squared is being cancelled out. Okay. So what's left is just the okay. It makes sense because it lies in the third quadrant, so it makes sense. So again, this guy should be something negative, right? what is A1? Oh yeah, never mind. Yeah, so this one should be positive until I work back because I'm only doubling the angle. Okay, I'm not doing the reflection yet. Okay, so yes, so this is exactly true. Okay, all right. So yeah. Okay, so this is equal to exactly 1 over, let's say, negative 4 n A1, A2 plus 2I n square A2 square minus A1 square. Okay. Okay, so I want to, because eventually I want to do some calculation by adding and subtracting. So this is not looking good to me. So I want you to erase the denominator, at least rationalize it. So how do I do so? So do I multiply by conjugates? Okay, so let's multiply by conjugates. So, okay, after I multiply by conjugates, minus, so this becomes the plus. Okay. So after I multiply by conjugates, then it becomes 16 n squared A1 squared plus A2 squared. Sorry, n squared A1 squared A2 squared plus. Okay. Oh, okay. So when I multiply by conjugates, so which is negative 4 A1 A2, sorry, negative 4 n A1 A2 minus 2I of this guy n2 A2 squared minus A1 squared. Okay. So now, so this becomes what? Actually, it becomes a plus, right? 4 wait, I have to have this guy squared actually. Shoot. Okay, so this one squared. Okay. So okay. Okay, so 4 times so this guy is squared. N to the 4th power A2 to the 4th power and then minus n squared a1 squared a2 squared. Okay. And then plus a1 to the fourth power. Okay. Oh shoot. I think that becomes a pretty nice expression here. So, right. So, because there is a 16 here, right? So, okay. So this cancel out with this middle guy, but there's an 8 left, so it becomes a plus. Okay. Okay. Okay, so okay, so then it becomes so this bottom just becomes what? This bottom just becomes so this is equal to, so same thing at the top, okay. And a1, a2 minus 2i. Okay, same thing. N squared, a2 squared minus a1 squared. Okay, so yeah, so this is a fraction, okay. And then so this is equal to, let me write this. Okay. Yeah. So this is, and then the bottom becomes what? The bottom becomes 4 times n squared a2 squared plus a1 squared. Okay. Okay, so this is one term. Okay. So remember that we are summing over this n from k plus 1 to this infinity, right? Okay. Okay. Yeah, so actually let me write it down so that I won't do the same computation next time. And then let's do the computation next time. Okay. Alright, yeah, let's end it here.